this problem says to derive a formula for the surface area of a sphere. Now, of course, we know the answer. We know the answer should be 4 pi r squared for where the radius of the sphere is r. But our goal is to derive it. So let's draw a picture to illustrate how exactly our method will work. So here's the 2D version of the problem. Circle with radius r. And we need to find the surface area of this. And we've got a formula for it, and how it works is to make a tiny band on the circle, or on the sphere, very narrow, which I'll call it color red here. Notice the dotted boundary is technically behind the sphere, so we can't see it. I just kind of made it slightly transparent so we can. So the formula we have, area equals the integral of 2 pi times y times ds. So 2 pi y is the distance around the band, and ds is the length of a tiny arc where it's touching, this band touches the edge of the sphere. So what we get is the distance around the band multiplied by the width of the band, essentially. Now, we learned that ds can be written more simply as, I don't know if more simply, but in a way that's easier to compute, as 1 plus y prime to the second power dx. And we can integrate from negative r to r, although it's a bit simpler if we do 2 times the integral from 0 to r. So that'll just find the surface area of the right half of the sphere, which by symmetry we know is equal to the area of the left half. So first we can factor out some constants. 4 pi, which sounds good. We know that's supposed to be in the answer eventually. And then instead of y, we'll put the formula for the circle, which is big R squared minus x squared under the root. And y prime, similarly, we can compute as 1/2 times r squared minus x squared to the negative 1/2 times negative 2x using the chain rule, which we can simplify to negative x over the square root of r squared minus x squared. So we've got y prime and we've got y, so we'll plug those into our formula here. So instead of y, I've got square root of r squared minus x squared. Instead of y prime, I've got negative x over root r squared minus x squared, all to the second power dx. So continuing on, inside the root, we can write this a bit differently. We can actually do the square to get x squared over r squared minus x squared. So since we have a root of r squared minus x squared and a root of this other stuff, I can multiply them together under the root. If I do that, I get r squared minus x squared plus x squared dx, which is simply 4 pi times the integral from 0 to r of the root of r squared dx. The root of r squared is of course just r, so that pulls out to the front. 4 pi r times the integral from 0 to r dx, which is just the integral of 1, so 4 pi r x. Plug in r and 0 to get 4 pi r squared for our area, as we knew it should be.